And welcome to the second lesson on functions. We're going to talk about absolute value functions in this video. An absolute value function is pretty easy to work with. Absolute value is just the distance a number is from 0. And the way that we would write this function is we have these two little lines that represent absolute value. Okay, you could have an expression in there, like maybe 3x plus 2, which we'll see something like that, similar to that, coming up in the video. Okay, so when we're talking about absolute value, if we had something like the absolute value of 5, we're just looking for how far away is 5 from 0. That's really simple. It's 5 units away. Where absolute values really work their magic is with negative numbers. So let's take a look at how they work with, say, a number line. Okay, for example, if we want to evaluate f at -3, where we're doing the absolute value of -3, what we'd be looking at is, on a number line, -3 is 3 units away from 0. So even though we're evaluating a negative number, we end up getting a positive value back. Okay, so we would see that f evaluated at -3, in other words, the absolute value of -3 is 3, because it's 3 units away from 0. Same idea with this value, -8. If we evaluate f at -8, we can see that -8 is just 8 units away from 0. So f evaluated at -8, the absolute value of -8 is really 8. Okay, so when we start getting into slightly more complex absolute value functions, we can do more than just how far away is it. We can actually work with expressions as well. Okay, so here they want us to evaluate at 2, -3, and -10. So let's see how these ones come out. If we evaluate at 2, that means we want to do the absolute value of 3 times 2. Also, we have this negative we don't want to forget. So 3 times 2 is 6. So it's asking us for the negative absolute value of 6. Well, the absolute value of 6 is 6 times that -1 would be -6. Second problem, f of -3. We have a negative absolute of 3 times -3. Let's deal with this inside first. 3 times -3 is -9. Here's where the absolute value comes into play, right? We have the absolute of -9 is going to give us +9. So we have this negative times +9 now, which will give us a result of just plain old -9. Last, we have f of -10. So we're doing 3 times -10. Inside, we have that negative on the outside we can't forget. So 3 times -10 is -30. The absolute value of -30 is +30. Multiplying by that negative on the outside, that gives us a result of -30. Okay, pretty easy stuff to work with. Let's try another one. Here they want us to evaluate f of x at the absolute value of opposite of x divided by 2 plus 3. So there's a couple of things we've got to deal with, and we're evaluating at -6, 4, and 18. So let's do each of these step by step. Let's do -6 first. So we've got to do the absolute value of opposite of -6 over 2 plus 3. Well, -6 is +6, so the absolute of 6 over 2 plus 3. Absolute value of 6 is 6, divided by 2 is 3, so that gives us 3 plus 3, which equals 6. Let's do f at 4. We want the opposite of 4 divided by 2 plus 3. The opposite of 4 is negative 4. The absolute value of negative 4 is positive 4. Positive 4 divided by 2 plus 3. So positive 4 divided by 2 is 2 plus 3 is 5. Got one more to go. Let's evaluate negative 18. So we have the absolute opposite of negative 18. Right, negative, negative, that becomes positive in a moment. Positive 18. Absolute value of 18 is 18. Divided by 2 is 9. So we have 9 plus 3, which is 12. Okay, so I've got a couple for you to try out. Here's the expression that you're going to evaluate at 10, negative 6, and 3. Pause the video, see how you do with those, and then resume to see the solutions. Okay, let's check these out. Here we have f evaluated at 10. So you've got two different functions that you're evaluating at 10. Right? We've got 2 times 10 minus 10. So 2 times 10 would be 20 minus absolute value of 10. So that's just plain old 20 minus 10, which is 10. Here we're going to do f evaluated at negative 6. So 2 times negative 6 minus absolute value of negative 6. Alright, 2 times negative 6 is negative 12. Now we've got the absolute. That's going to help us out here. Absolute value of negative 12 is 12. Absolute value of negative 6 is 6. 12 minus 6 gives us 6. And our last one, negative 3. Absolute value of 2 times negative 3 minus absolute value of negative 3. 2 times negative 3 is negative 6. And again, our absolute values come into play here. Absolute value of negative 6 is 6. Absolute value of negative 3 is 3. 6 minus 3 is 3. Alright, that's how absolute value functions work. Pretty easy to do. Now let's take a look at what their graphs look like. Okay, so we'll go in more detail about how to manipulate these graphs, but we're just going to see the general shape of the graphs. They're pretty easy to work with as far as graphing goes, because it doesn't matter if we plug in a negative to x, it's going to give us a positive y value. So generally speaking, you're going to see that for every positive 1 will get out 1, 2 will get out 2. So it's going to kind of go like this way for the positives. But now when you start talking about the negatives, if I plug in negative 1, we know we get 1 out. Negative 2, we get positive 2 out. So what we're seeing on the negative side is that it's also going to head up this way. So it's going to kind of look like a V. But now we have different things happening as well. So not only is it going to be becoming positive here, but we're going to subtract 2 from our solutions. So let's see what this whole thing looks like. I'm going to come up with a few values to plug in on the negative side. Let's do negative 4, 3, 2, 1. And then I'll do a couple positives as well. How about positive 1, 2, 3, and 4? Okay. So I'm not going to draw out all the math for this. I'm just going to do it real quick. Absolute value of negative 4 is 4. Minus 2 is 2. So my y result here is 2. So negative 4 and 2, that puts us up here. Absolute value of negative 3 is 3. Minus 2 is 1. So negative 3, 1. Absolute value of negative 2 is 2. Minus 2 is 0. So negative 2, 0. Hopefully you're starting to notice that it's going the way that we had predicted. Right? Absolute value of -1 is 1 minus 2, -1. Absolute value of 0 is 0 minus 2 is -2. So let's see, -1, -1, 0, -2. Absolute value of 1 is 1 minus 2 is -1. So this is where we're starting to see that it's starting to go back up, right? On this side, it was starting to kind of head down until it got to a certain point. Now we're starting to see it go back up. Once we start plugging in more values, like 2 would give us 2 minus 2 is 0. We can see exactly where it's heading. Okay, if I was to plug in the rest of those values, you'd start to see what we get for the rest of them. 3, 1, 4, 2. Okay, that general V shape of an absolute value. So here's a much more tricky one. Okay, take your time, plug in some numbers. I would say do the same values that we did in the problem before. Start from -4, end at 4, come up with a table of values and plot it out. So pause the video, try this one, and see what you come up with. Alright, let's check it out. So I had suggested for your inputs, go from -4 up to +4. So -4 plus 1 is -3. The absolute value of -3 is +3 times -2 is -6. So I got -4, -6. -3 plus 1 is -2. Absolute of -2 is +2 times -2 is -4. -2 times, plus 1 is -1. Absolute of -1 is 1 times -2, -2. -1 plus 1 is 0. Absolute of 0 is 0 times -2. That gives us 0 here. 0 plus 1 is 1. Absolute of 1 is 1 times -2, -2. Hopefully we start to see that. Okay, it gets to a certain point, and it's going to start going backwards now. All right, 1 plus 1 is 2. Absolute is 2 times -2 would be -4. Okay, we can start seeing we're going to get -6, -8 most likely, -10. All right, we can check these if we need to. 3 times -2 is -6. 4 times -2 is -8. Okay, so these values seem to be working out real nice. And if we graph it, 1, 2, 3, 4, -6, okay, -3, -4, -2, -2, -1, 0, -0, -2, 1, -4, 3, -2, -6, 3, -8. I've actually run out of space on my graph. Okay, but that's the general shape. Hopefully you came up with that same graph on that problem. So that's it for absolute value functions. We will definitely go into more detail about them later on, but for right now, that's a pretty good look at them.